All right, so why don't you go ahead and take a minute and check your Lewis symbols. Please note that any of the elements that are in the same group or the same column, that they all have the same type of Lewis symbol. So if we look at these first 5 here, nitrogen down through bismuth, they all have 5 valence electrons. They all have different number of core electrons, but they all have 5 valence electrons. All right, so as we go forward, let's start to draw some more Lewis structures. And so here's some guidelines that will help you to determine whether or not you have a good Lewis structure or not. So the first thing that you want to make sure is that all the valence electrons appear in the structure. Whenever we do have electrons, they tend to be paired, either as a lone pair or they're a shared pair or a bond. We aren't going to have any radicals, so any lone electrons. So look for paired electrons that are either a lone pair or shared, which would be a bond. Okay, and then we're always trying to fill up an outer shell if possible. We're trying to achieve that octet, or in the case of hydrogen, just 2 outer shell electrons. And then as we progress in this unit, sometimes we'll need to form multiple covalent bonds, but usually whenever we're doing that, we'll start to look at formal charges and things like that. So let's go ahead and try a few examples first. All right, so let's look at F2. We're going to look at fluorine. All right, so fluorine, we want to figure out how many valence electrons we have. Well, fluorine is a halogen, and all the halogens have 7 valence electrons, so we have 7 plus 7, so we have a total of 14 valence electrons. So whenever we look at this, let's go ahead and draw the Lewis symbol for each fluorine. So there's one fluorine. So notice that there's 3 lone pairs and then 1 single electron. And then over here, we have a second fluorine atom. And again, we have 3 lone pairs with a single electron. So what we should be able to see is that if these 2 fluorine atoms each share an electron, each contribute an electron, that they can end up each obeying the octet rule. So let me show you what I mean really quick. So if we were to draw this like here, where we can see that these electrons are shared, okay, well let's go through and count all of our electrons to make sure that we have them. Okay, so if we accounted for all the valence electrons, well, each fluorine atom is contributing 7. So that's a total of 14, so we've taken care of that. All the electrons are paired, either as a lone pair or a bond. And then now does each atom obey the octet rule? So let's go ahead and erase this fluorine on the right except for the electron that's being shared. Okay, so we can see there that fluorine obeys the octet rule, 2, 4, 6, 8 electrons around it. And then we can erase the fluorine on the left, and we can see that the same is true for the fluorine atom on the right. So this would be a good Lewis structure because all the valence electrons are present, everything obeys the octet rule, all the electrons are paired, so we're in good shape. All right, let's go ahead and consider another example, CH4. Okay, so whenever we are drawing these Lewis structures, we want to try to make them as symmetric as possible. So we need to get some vocabulary out of the way. We need to start to define the difference between a central and a terminal atom. So a central atom is one that is bonded to 2 or more things, whereas a terminal atom is only bonded to 1 other atom. So let's go ahead for CH4, methane. Let's go through and figure out how many valence electrons we have. Okay, well, carbon contributes 4 valence electrons. Then each hydrogen atom has 1. There's 4 of those, so we have 4 plus 4 for a total of 8 valence electrons. So if we were to go ahead and draw out the Lewis symbol for carbon, okay, so if we draw it like this, we can see that we have 4 electrons for carbon, and then we probably starting to already visualize that if we add a hydrogen on each side, that we can start to see that carbon has now completed its octet. Okay, if we cover up all the hydrogen atoms and show the electrons that are shared, carbon has 8 electrons all around it. If we were to go through and take away carbon and the electrons that it's sharing with other hydrogen atoms, we can see that each hydrogen atom would end up having a filled outer shell. So all of these have reached that criteria. All the electrons are paired, or in this case they're shared pairs, so they're bonds. So what we have here is yet again another good Lewis structure. And as you draw these more and more, they're going to become easier and easier to draw. You're going to start to get a little better with your chemical intuition and predicting what they look like. All right, so let's go ahead and try another set. Let's look at H2O. All right, so the first thing that we want to do is look at H2O. So if we're trying to make this symmetric, one of the things that I want to go back and point out about CH4 is that carbon is our central atom. Carbon is always a central atom for us. Okay? And terminal atoms are things that are only bonded to one or more things. For us, hydrogen is always a terminal atom. Okay, so hydrogen should only be bonded to one thing. So we aren't going to have a Lewis structure where it looks like hydrogen, 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 carbon, or anything like that. So let's go ahead and try to apply that to our next Lewis structure for water. Okay, so how many valence electrons do we have? Well, we have 2 hydrogens, each contributing 1 valence electron, so that's 2, plus 6 from the oxygen, so that's a total of 8. All right, so if we start to consider what this structure is going to look like, we'll go ahead and draw out the Lewis symbol for oxygen first, which has 6 valence electrons. But then we just said that hydrogen has to be a terminal atom. Okay, so hydrogen will be bonded to oxygen. It can't be bonded to another hydrogen and then to oxygen. So it's going to look like this. Okay, so as we're looking at this, have we accounted for all the valence electrons? Well, we have 6 from the oxygen and then 1 from each hydrogen, so that's our 8 valence electrons. All the electrons we either have lone pairs or bonds. And then does each atom have a filled outer shell? Well, let's look at the hydrogens. If we take away oxygen and its lone pairs, both of those hydrogens have a filled outer shell. And then if we were to take away hydrogen and leave its shared electrons, we can see that oxygen has an octet there. So this is a good Lewis structure. And again, another way that we'll draw this is instead of having the dots there, we will just put the bonds in. All right, last one for this lesson. So let's look at HF. Okay, so hydrogen fluoride. So how many valence electrons does hydrogen have? Well, hydrogen has 1 valence electron. Fluorine has 7. So we have a total of 8 valence electrons. So whenever we draw this out, you're probably already starting to visualize this, but hydrogen has 1 valence electron, and then fluorine has 7. Okay, so hopefully you can see that again, all the valence electrons are here. The electrons are paired. We have a bond, so this is yet again another good Lewis structure. All right, so next time we'll start to look at formal charge, and then we will also be looking at charged species, and then also looking at whenever we need to form a double or a triple bond, so if we need to form a multiple bond.